All right, so PST and DOS, what those actually mean. PST is a perfect square trinomial. DOS is the difference of squares. These are special kind of shortcuts for factoring. Perfect square trinomial. A trinomial has 3 terms. Difference of squares. Difference of squares are going to have 2 terms. Now for both of these, we're using the word square. What does it mean when we're talking about squares here in algebra class? Tom?
Something times itself.
Exactly. 1 times 1 is 1. 2 times 2, 4. 3 times 3, 9. 16, 25, and so on. So here's the list of your first 10 perfect squares, and we could go on forever. Anything times itself is going to be a perfect square. Now we're asked to factor x squared minus 25. Yeah, go ahead. Right now, you guys don't know how to factor x squared minus 25. You know how to factor trinomials. This isn't a trinomial. You know how to factor using a GCF. No GCF between x squared and 25. This is where difference of squares comes into play. We call it the difference of squares because x squared is a perfect square, 25 is a perfect square. What does the difference mean? Tyler?
You subtract them?
Yeah, that's exactly what it means. It means subtraction. So when you have the difference of squares, here is your rule. If you have a squared minus b squared, your answer is just going to be a plus b, a minus b. So if we would have x squared minus 25, our answer is going to be x plus 5, x minus 5. You just take the square root of x squared and the square root of 25. 1 is plus and 1 is minus. Hannah.
Are they all going to be able to be factored? Like, they're all going to have...
If they're a difference of squares, yep. If they're a difference of squares, yep, you can factor all of them just like this. But let's see why this works. I can tell you that, and you're right, it is really easy, but why does it work? Let's think of x squared minus 25 as a trinomial. We could rewrite this as x squared plus or minus 0x minus 25. So I kind of have a placeholder in there for my x, but the value of it is just 0. So it's not changing the value of x squared minus 25. Now, using your rules for trinomials, our last term is negative, so signs are different. What factors of 25 would add together to give you 0? Because look, we have 0 in there as our middle term. What factors would add together to give you 0, Denny? 5 and 5. And if you're trying to find 2 factors that are going to add together to give you 0, those numbers have to be the same numbers, just opposites. So that's why difference of squares always works with plus and minus the same number. Who would like to try number 1 for me? Mike.
X plus 7 and x minus 7.
Perfect. For number 2, we need to take a step before we factor. Nate? Is that a hand? Kind of. Hannah?
You have to subtract 100 onto the other side.
Yes, we need to get this all on the same side of the equation. So we've got x squared minus 100. And in factored form? Mike?
X plus 10, x minus 10.
Right. you'll recognize in 3 and 4 that we have coefficients on our a term, or coefficients as our a's. We don't just have x squared. But as long as they're a perfect square, we still do the same thing. So 16 is a perfect square. So 16x squared minus 121 is still the difference of squares. Would anybody like to try to answer it for me? Ryan?
Would be 4x minus 11 and 4x plus 11.
Good job. And number 4. Nate.
2x plus 3y. 2x minus 3.
That's right. So anytime you have two terms and they're separated by a minus, so you're subtracting two terms, check for difference of squares. Hannah, question?
So it's the same for all of them, it's just the signs.
Yep, one's positive, one's negative. Now I want you guys to do numbers 5 and 6. You're just factoring the trinomial, just like you did when we started this way back last week. You're setting up two sets of parentheses. Look at the last term to decide if your signs are the same or different. Take a minute to go ahead and do those two. Who's going to tell me your answer for number 5? Nick.
X plus 6 times x plus 6.
You got it. How about number 6? Sean.
Alright, x minus 12 times x minus 12.
Good.
That's easy, I thought it.
That is pretty easy, Denny.
Never mind.
Okay.
I put my papers in the wrong order.
For paper.
Does anybody know how else we could write these? John?
Everyone combine them and write square.
That's exactly what we could do. This is the same as saying x plus 6 quantity squared, or x minus 12 quantity squared. Well, why is this helpful? For these ones weren't very difficult ones. But this is a super duper helpful shortcut for whenever you're factoring perfect square trinomials, because it saves you a lot of work. A perfect square trinomial is a trinomial, so it has 3 terms. The perfect square part means that your first and your last term are perfect squares. So for a perfect square trinomial, your A and C terms, or the first and the last terms, are perfect squares. If you look at these, x squared, 36. Yep, those are perfect squares. X squared, 144. Yep, those are perfect squares. What else? For a perfect square trinomial, your last term, your C term, is going to be positive. Does anybody have an idea why we would have to have our last term positive? This process is going to give us a shortcut, so we can write our answers as a binomial squared, a quantity squared. Why would the last term be positive, Tyler?
Because then it wouldn't be, you couldn't square it because it would have to be one positive and one negative.
Yeah, I think you were saying the right thing. You just said it in a little bit of a backwards kind of way, because the signs have to be what if you're squaring it?
Different.
The same.
Oh,
If
yeah.
you're
Oh, yeah. If you're
yes.
squaring. Yeah, that's what I meant.
Yes, if you're squaring something, you're doing the exact same thing twice. So you're going to have the exact same signs.
Yeah.
Last term positive tells you to have the same signs. Now, the only thing that gets a little bit tricky here with the perfect square trinomials is understanding the middle term. The middle term is equal to 2 times the square root of AC. when you're doing these, you don't need to find the middle term. You just need to be able to recognize, does this middle term make it a perfect square trinomial? Does this middle term let me take the shortcut? Tom?
So, if you didn't have the middle term and you just had A and C, you could times by 2 and take the square root of it and you would get middle term.
Say that again?
If you have one of these problems
Mm-hmm.
and they don't give you the middle term,
They will give you the middle term.
but if they don't, can you still solve it?
You wouldn't be able to solve it using this method
Why not?
because you have to have the middle term for this method.
What if it says the middle term is equal to that?
Yeah.
If you had A and C, then couldn't you find the middle term?
But if they're not giving you the middle term, then you wouldn't know that it's equal to that. They have to give you the middle term.
Okay.
Yeah, they have to give it to you. Yeah. So what we're saying here, the middle term is 2 times the square root of AC. What's the square root of x squared? Right, it's just x. What's the square root of 36? 6. There were a lot of whispers. Yes, 6. So AC is 6x. If I would multiply that by 2, I would get what? 12x, which is the middle term. Okay? You don't need to show this work. I'm just showing you where the middle term is coming from. If you're looking at number 6, AC would be 144x squared. So if you took the square root of that, you would get what? 12x. And we said that the middle term has to be 2 times that square root, so 24x. Sure enough, it is. So that's just kind of your double check to see if the middle term lets you do this shortcut.
So you take the last, do the square root and then multiply the square root times 2.
Yep, that's exactly
and
it.
then if it matches the one in the middle, then you can do that.
Then you can do your shortcut. Yep,
Awesome.
that's it.
Awesome.
All right, so looking at number 7, you want to check a couple things. Do I have a perfect square as my first and my last term?
Yes.
Yes, I sure do. Is my last term positive?
Yes.
Yes, it is. Is my middle term the 2 times the square root of AC?
Yes.
Yes. So I can make a shortcut here, and I can just say, okay, to factor this, I just need x minus square root of 25 is 5, quantity squared. How did I know that was a minus and not a plus? Tyler?
Because the middle term is minus.
Yes, right. Okay, for number 8, check your first and your last term to make sure that they're perfect squares. Check the last term to make sure it's negative. To make sure it's positive. Check your middle term is 2 times the square root of AC. And then if all those things are true, we can make our shortcut the binomial squared. Sean? Close. 2x plus, what's the square root of 9? Yeah, 2x plus 3 quantity squared. Good. What about number 9? No. Why not? Go ahead, Anna.
Because the last term is negative.
Right. And what else is true about the last term? Nate? Right. So on your homework, it's going to ask you if it can't be factored to say why. So we can say that our last term is negative and that our last term is not a perfect square. And then number 10, check your first and your last term to make sure that they're perfect squares. Check your middle term to see if it is 2 times the square root of AC. Anybody have an answer for number 10? Yes. Who said yes?
John.
John. Go ahead.
Oh, 6x plus 11.
Look at your middle term for the next sign.
Minus.
Yeah, 6x minus 11 quantity squared. Now this is just a shortcut. This is a shortcut for whenever you have a trinomial and you recognize that the first and the last term are perfect squares. Could you do these another way? Sure. You could do them by our regular factoring. You could do it by the garbage method. But this is a shortcut to save you a bunch of work.